In this video, I'll be covering the progress I've been making bringing Sonic the Hedgehog from the Sega Megadrive to the Amiga computer. Plus, I've been talking with Neil Harding, who worked on Sonic 3D Blast for the Megadrive and the Sega Saturn, plus many other iconic Amiga and ST games. Over the past few weeks, I've got Megadrive-style sprites rendering on the Amiga, the Sonic animation system ported, and even some of the level rendering code started. Whilst before we only had the initial Sega logo displaying, we're now up to the game's title card. Yes, it has taken multiple weeks of programming just to get this far. Originally, I'd intended to jump straight in and render a level, but the further I delved into the game's codebase, the more I realised that that was, well, maybe a little bit ambitious, and I needed to walk before myself or Sonic could run. After the Sega logo, the game shows this simple Sonic Team Presents banner. You might be wondering why Sega chose to waste boot time with this simplistic screen. In fact, this screen is really more of a loading screen. Behind the scenes, the game engine is decompressing a huge amount of graphical data. The graphics data is needed for the main title card and the demo mode. One other intriguing Sonic Easter egg is that this screen hides some invisible Japanese development credits. Through a combination of button presses that's way too long for me to read out, you can set the background colour to white instead of black. Now, because the font is black, the secret credits now become visible. The other interesting thing about this screen that surprised me is that the letters are built from sprites rather than tiles. For the Amiga port, this meant it could serve as a very simple sprite test, almost like my own personal Hello World application. I'm not using the Amiga sprite hardware to handle Megadrive sprites, as it's too limited. Instead, I'm using the Amiga's Blitter hardware to render them. For clarity, I'll use the term sprite to refer to a Megadrive style sprite rather than an Amiga hardware sprite. What does the Amiga's Blitter do? Well, it can perform a whole bunch of things from line drawing and area fills through to moving data or graphics around. On the one hand, as a developer, it doesn't do anything you couldn't code by hand. However, it will often do it a lot faster, up to 4 times as fast on a stock Amiga roughly. For example, let's say I want to render a graphic with transparency over a background. For example, Sonic himself in this sequence. If I was to code this by hand, the assembly code would look something like this, where firstly I need to sample the existing background layer. I then need to mask the new graphics data to maintain transparency, effectively removing the background so it's not copied, or we'd end up with a solid block behind the image. Then I need to merge the masked graphics data with the background layer. And finally, I need to do this for every group of pixels on every single bit plane. Before you know it, all your CPU cycles will be dominated by screen rendering alone. Furthermore, a sprite is a freely placeable object. If I want to draw it at screen coordinate x3, that's very easy to do on the Megadrive, but the Amiga is bitplane based. Each byte represents 8 horizontal pixels. Advancing a byte advances 8 pixels at a time. So it's easy to render at positions 0, 8, 16, 24, etc. But what if I want to render at pixel 3, which I need to do for smooth movement and precision placement? To render at pixel x3, I would need to perform bitwise manipulation on both byte 1 and byte 2 of the data, because an 8 pixel wide sprite would overlap both bytes. This would involve rotating bits in 2 bytes of the screen data, which adds a huge amount of computational overhead. The Blitter solves this problem by allowing you to more easily draw to the screen coordinates you need with freely placeable objects. These are called BOBs, Blitter objects. Some talk about the AMIGA's Blitter in mystical terms, but in reality it's pretty essential if you want to create complex 2D action games on lower-end AMIGAs. Without it, you'd be reliant on expensive CPU calculations, or the AMIGA's limited sprite support just to move and animate your characters. If we amend our previous model, we can see that the Blitter also shifts the source data for us too, so we can smoothly move objects around the screen. We program the Blitter with a min-term equation that effectively summarizes how we want the data to be processed. All those manual lines of code become one equation. Without the Blitter, we would have coded this manually and put the load on the CPU. By offloading the work to the Blitter, we get faster results. My approach to Sonic is to try and get things up and running as fast as I possibly can. I'm not interested in optimization or silky smooth performance at this stage. The reason is that I need to get further into the journey before I can truly understand the smartest optimizations to make. If I apply them too soon, I'll tie myself in knots and the project will never be finished. In a few months' time, I can almost guarantee that the graphics code that I'm writing today will have all been rewritten, improved, and replaced. It's a little like restoring a classic car, where by the end you're left with very little of the original rusty bodywork that you started with. But having that original bodywork was the essential scaffolding you needed as an engineer to build the project around. One complication in using the Blitter for Megadrive sprites is that Megadrive sprites can be all kinds of sizes. Megadrive sprites are built by arranging 8x8 pixel tiles in 16 different arrangements. The Blitter prefers to work with word-sized pieces of data, that is to say 16 pixels wide. In addition, if we want graphics to draw at an x-coordinate that isn't a multiple of 8, we need to pad the source graphic with blank space, because the Blitter rotates the data through this padded area. Megadrive tiles are tightly packed to squeeze as many into RAM as possible. There's no padding, so we're going to need to rearrange them all prior to blitting them to the screen. Right now I'm doing this at runtime, which is horrendously slow and not a good idea. But further down the line, I'll pre-arrange the data used by the sprites in a Blitter-friendly format. I'm not doing this now because it will make debugging graphical issues more complex, and I'm not far enough into the project. Honestly, sprites are one area of mastery for the Megadrive. They are far easier to work with and more memory efficient than AMIGA bobs. Any project of this nature involves a lot of head-scratching moments. Often I can spend a day or so bashing my head against a wall trying to solve a problem the wrong way. One example of this is how Sonic's body is masked behind the central circle. Without clipping, he'd look like this. How offensive. In fact, some of the early Megadrive emulators in the late 1990s had this exact bug because the hardware wasn't fully understood. I naively assumed this effect was achieved by using the Megadrive's relatively competent layer priority system. This enables the programmer to rearrange almost every layer of the graphical display. It's responsible for how Sonic can run in front of and behind the trees. It's a really neat and powerful system. However, the title card actually exploits a bug or quirk in the video hardware. If the programmer tries to render more than 320 pixels of sprite data on a scan line, the hardware effectively says, "No more," and stops rendering. If you look at the sprite area, you'll spot that the game renders a load of overlapping junk sprites outside of the visible display window. This causes Sonic's belly not to render, because in doing so, we'd be rendering over 320 pixels of data for each of these lines. The other interesting quirk of the sprite hardware is that it uses front-to-back rendering, so it draws the sprites in front first, whereas we want to draw the sprites from the back first, then render over them back to front. Amusingly, if you get this the wrong way round, Sonic looks a lot more jolly on the title screen as his slight frown isn't drawn over his face. The original game has a hidden level selection screen. Depending on the precise revision of Sonic you're using, this can be entered through the combination up, down, left, right, then holding A and start. I've ported this over and mapped the AMIGA keyboard to the Megadrive pad so the screen can be navigated. Whilst I can't actually get into a level yet, this will be incredibly useful to test parts of the game, and I would have had to have coded something like this myself regardless. Interestingly, this menu uses the priority system I mentioned previously. The logo and sprites are shifted into the background, and the text is prioritized and displayed over the top. Currently, there's some screen corruption when I navigate the menu. I haven't tracked down the issue yet. Now, on the one hand, you might be saying, Chris, you've worked on this project for nearly 2 months now, and you're not even into the gameplay yet. And yes, that is a valid concern. In fact, the length of time you can spend in the wilderness on projects like this, with little to show for what you've been doing, often discourages people from taking them on or causes them to give up. What seems like a simple job on paper, porting some 68,000 code from one platform to another, actually unravels into many, many challenges when put into practice. The way I stay motivated is by understanding that everything I'm doing, even just for this title card, is building towards something greater. For example, the background here is a tile map, but it's actually constructed in a different way to the tile maps used for the Sonic logo and the Sega logo. It's built from gigantic 256 by 256 pixel blocks. In turn, these are built from 16 by 16 pixel blocks, or effectively groups of 4 tiles. So at the lowest level, the background is composed of 8 by 8 tiles, but there's a whole software system built on top of these. Now, this is the exact format used in game. So by getting this working for the title card, we're closer to getting a real level running. These tile layers are also compressed with a different algorithm to the others we implemented in the previous episode for the Sega logo. In fact, the new decompression code completely crashed when I tried to execute it for the first time because it was writing directly to the processor's status register, which can only be done in supervisor mode. I rewrote that code to make it more AMIGA friendly. So all of this work is valuable and necessary to get us into the core mechanics of the game engine. The eagle-eyed amongst you will also notice that I've fixed a bug from the Megadrive version. The press start button text doesn't actually appear on the Megadrive version because of a bug in how the sprite memory is cleared. But here it is, working on the AMIGA. The obvious thing that's currently missing is the scrolling. This is actually one of the biggest challenges of the entire project, and it's the one I'll be tackling next. If I can solve it, then I'll be more confident that a high-quality version of Sonic is possible on the AMIGA. The reason it's challenging is because Sonic has 2 independently scrolling background layers. Whilst the AMIGA offers something similar with dual playfield mode, it comes with some serious colour palette limitations, and it also uses a lot of DMA bandwidth. Next, I'll be experimenting with a number of approaches, rendering a proper level and reporting back on my findings. One question that I was asked quite a lot after the last video was whether I could squeeze extra colours out of the AMIGA 500 version by using extra half bright mode, or EHB. Whilst I wouldn't rule it out, EHB comes with some challenges. It uses an extra bit plane for the screen display, which will immediately suck bandwidth and performance from the engine. Furthermore, I would need to investigate whether the Sonic palette benefits from the limited extra colours it offers. My intuition tells me that we'll have to radically rethink the background layers for the A500 anyway? Are 2 even possible? Will I be able to use the sprite layering trick to fake one of the layers that's common in many Amiga games? There are more questions at this stage than answers, so I'm just going to say, unfortunately, I don't know yet. Neil Harding, who worked on Sonic 3D Blast for the Sega Megadrive and Saturn, was kind enough to reach out and answer some of my questions.
Sega were developing their Sonic Extreme for the Saturn, and that didn't look that good for what people were expecting from a next generation thing. And so there was a lot more positive feedback for Sonic 3D Blast. And so it's like, we need something for Thanksgiving. And it's like, we literally started in July and had to have it in stores for Thanksgiving, which means that's the end of November. But because of production, that's means you've got to have it ready. You got to have it finished by the beginning of November. We'd not even seen the Saturn hardware at this point, so we had, it was trying to work out how we can do it. It's like, well, if we go for an emulator approach, then that might work, but it's going to be harder to try and make changes if we're doing it as an emulator. So let's convert the code. And if the code had been finished, it would have been one thing, but the game was still being developed. Having to port a program that's still under active development. So I was working like 100-hour weeks for pretty much the entire project.
Maybe, I think people watching this might be interested. What was the coolest development setup you got to work with? Any platform?
So I think one of the best ones was when I was working on the Sega Master System. We had a really, really expensive piece of kit that would allow you to replace the processor with this piece of hardware that emulated the Z80. You can set hardware breakpoints. So it was almost like a modern debugger, but it was actually even better than a modern debugger because it would keep track of how memory changed. So you could basically step backwards through the code once you hit a breakpoint, and you can say, oh, how did I get to this point? The Sega Master System had a really limited potential. To write to the video memory would take 29 cycles if it was during the active screen display, or 16 cycles during the VBlank. And so I was doing, it wasn't Outrun, but it was Rammer on every scan line, changing the scroll register to get the roads curving. It also changed the palette to get the road stripes. And then it was also downloading 4 bytes of data. And so I had 224 cycles, and it's like trying to squeeze as much as possible by encoding them. Okay, I can move the update a sprite, update some more data. So you're just trying to push everything together. I like a challenge, and that was a big challenge.
So this debugger, is it almost like a modern emulator would do loads of save states to let you rewind the game? Is it almost the equivalent of that?
So it basically did it every cycle, and so you could go back up to 4,000 cycles.
Thanks to everyone who's supporting the project, either on Patreon or simply by commenting on these videos. I'm doing my best to ensure I can get a new one out monthly and strike the right balance between making solid progress to present, but also not disappearing into a technical rabbit hole for months on end. Also, your donations have allowed me to buy a new microphone for Christmas. So maybe in the next video, I'll sound less like Moss from the IT crowd, although that's unlikely. Thanks to Adam for the Sonic jingle. I'll pop a link to his channel in the description. And thanks to Neil for reaching out and talking to me about old school development. It was really good fun. I'll be including a little more of that in later videos. Until next time, I wish you all a great Christmas and let me know what Santa brought to you in the comments below.